All right, so what if they tell you this now? We want to find a quadratic model for the sequence with these terms. And they tell us a sub 0 is -2, a sub 1 is 1, and a sub 3 is 13. So we're to come up with a quadratic model for a sequence that has those three terms. Quadratic model is going to look like what? And I've got to orient this again. Apparently it didn't take the first time. Or I didn't press directly in the center of the targets. Okay, so a sub n is going to equal what? I'm sorry. What does quadratic model look like? And I'm trying to make it a sub n. Sum a times n squared plus sum b times n plus c. Okay? So instead of giving us the first 3 or 5 terms, they gave us a random listing of them, didn't they? Okay? So it's not much different than yesterday. We just won't be working with the same numbers as we were yesterday. A sub 0 is a times 0 squared plus b times 0 plus c, and that's equal to a -2. A sub 1 is a times 1 squared plus b times 1 plus c, and that's equal to a +1. And a sub 3 is going to be a times 3 squared plus b times 3 plus c, and that's going to be equal to 13. So simplifying this first equation, our a sub 0 is going to say 0 plus 0 plus c equals -2, right? So they were kind enough to give us our c already. A sub 1 simplified says 1 times a plus 1 times b plus c equals 1. Oh, sorry, c equals -2. Does not look like an equals sign. Write that again. Okay, finally simplifying our third equation. It's going to say 9a plus 3b plus c equals 13. So we know c, don't we? Let's sub it in. A plus b plus a -2 equals 1. So a plus b will be equal to adding 2 to both sides. A plus b will be 3. And we had a 9a plus 3b minus 2 equals 13. Adding 2 to both sides, 9a plus 3b will be equal to adding to 15. We could simplify that. I would recommend, since they all have a 3 in common, reducing, dividing by 3. In fact, let's divide it by -3. then we can add the two together. So if I'm going to divide everybody by -3, common term, greatest common factor, we'll have a -3a minus b equals -5. If I add that to a plus b equals 3, -2a equals -2. So a is 1. And find the easiest place to plug it back in. Most convenient place is likely here. 1 plus b equals 3. So b equals 2. So my new sequence, a is 1, so n squared, b is 2, 2n, and c they told us was -2. Be okay with that one? All right. Same idea. Absolutely, I'm sorry. Need to see another example, or is everybody okay? See another one? Okay. All right. So this time they gave us our a sub 1, 2, and 3. I don't think I have a third one. Yep, I don't. Okay, so this will be similar to what we did yesterday. Okay. A sub 1 is -5. So that means that when I plug -5 in, or when I plug in 1 for my a n squared plus bn plus c, I'm going to get a plus b plus c is -5. Now when I plug 2 in for my n's, we're going to get 4a plus 2b plus c, and that will be equal to -5 as well. Now when we plug in our a sub 3, 3 squared plus 3b plus c will get us -3. Back to what we did yesterday. Eliminating the variables. C is the easiest one to eliminate. So if I take a sub 3 minus a sub 2, I'll have 9a minus 4a, 3b minus 2b, c minus c, and -3 minus a minus 5. Then let's take a sub 1 minus a sub 2, a minus 4a, b minus 2b, c minus c, and -5 minus a minus 5. Adding the two equations, we've eliminated a, we're eliminating b now. So we'll have a 2a equals 2. So a is 1. Now that we know that a is 1, pick a convenient spot. Doesn't matter which one. -3 times 1 minus b is 0. So -3 brought to the other side will be a +3. So b will be -3. And finally, we need to find out what c is. First equation is the most convenient. So 1 minus 3 plus c is a -5. We have a -2 here. When we add it to both sides, we will have +2 on the other side, -3. Sequence equation, n squared minus 3n minus 3. Okay. Assignment. It's 4 easy problems. Being too easy on you. Same page, I think. I'll have to find it just a second.